Hello everyone, this is Shan from VKS, back again with another interesting guidebook of the week series. This week we'll be looking at extrusion process, to be more specific, extrusion of plastic tubing. This is relevant to anyone extruding metal, plastic, or any other materials. Not just for extrusion process, we have added some interesting features and elements to this guidebook that might be insightful for anyone looking into standardizing their process and also adding traceability. Before we dive into the guidebook, please hit that like button and subscribe to get more updates on our upcoming Guidebook of the Week series. So let's just go on and dive into the guidebook here. So we'll start by clicking on the start button here. And before we start the work instruction, we are prompted by a production information form. So these are customizable forms that can be added within your work instruction, and you can have it triggered at any point within your work instruction, either before the step, right after the step, or at any point within the cycle. Here we have some fields that we are required to fill out. So the work order number, again, this can be a work order number, a production order number, or anything as you like. That you think would be important to collect the data that you need. So the work order number can be this specific number here. And I do want to note that anytime you have a red dot beside a field, that it's mandatory to input that information. Here we have the two other fields that are pre-populated already. Number of expected 50 meter spool, 100, total production time in minutes, 50. Once that information gets saved, that goes into your productivity monitoring information table here. Here, as you can see, you have your expected work time, expected units, cycle time, and cycles. And here it records you live how long you've taken to complete the job, how many units you have completed, cycle time, and cycle, so you can kind of compare the two. Moving down here, we have some elements, and these are thing that I've mentioned in the beginning is some interesting elements and features that we've added to this work instruction. So we have an attachment, a JPEG attachment of a schematic drawing of the extruder. You can refer to this at any time. It's good to note that you refer to all of these elements before starting the job so you can be familiarized with some of the elements that have been added and not be surprised by it. So as you can see with the schematic drawing of the extruder, you can look into all of the parts here just to familiarize yourself with the machine. Let's say you're not highly experienced with this type of process. You might have to look into this drawing to see where each and every part is. So with this picture, you can add an AutoCAD drawing, SolidWorks drawing, 2D, 3D models, and they can always refer to this attachment at any time within the work instruction. We have a PDF file of the spec sheet of the machine here. And again, they can refer to this document at any time. And we have some forms that we've added that we will be seeing throughout the work instruction. So we have a validation form, production information form, and a quantity completed. And then we have a link of a handbook. So a handbook or any type of link can be added within your work instruction. So let's take a look at this link very quickly. So this is an extrusion processor's handbook. Let's say the operator needs to refer to this at any time to look at certain processes, how certain things work, or educate themselves on pretty much anything. They can always look at this handbook. So this handbook is always handy within the work instruction. Let's start off with the step. So our first step is basically a setup step showing the machine. Now you can start off with a workstation setup. You can start off with a picture, video, text step, however you want to start off your first step. So we have a header here, extrusion of plastic tubing. We have the name of the machine that we are working with, which is the TDD-P series single screw extruder. We've hyperlinked this annotation. So you can add links to the annotation. You can hyperlink it to either bring them to a external page, external website, video, or a spec sheet, information sheet, anything as you like. Let's move on to the next step here. Before moving on to the next step, we have a validation form. So again, as you can see, this is triggered right before you go on to the next step or right after this step. Make sure to review the schematic drawing of the extruder attachment before starting the process. Again, in this case, it's very important that they go over the drawing to familiarize themselves with where each and every part is. And let's say I'm the end user, I confirm that, save. Moving on to the next step, get your base material ready for extruding. What is the base material dealing with? We've added a note for that. So you can add droplets as one of your annotations to indicate what type of part that you're dealing with. Anytime you want to add notes. So a yellow droplet is indicated as anytime you want to add notes. You can use it in any situation as you like. You can use it however the way you want as well. So here's indicating tiny pellets of polyurethane. Now you can add more information to this by adding more instruction to this droplet, but we just kept it simple by it just indicating tiny pellets of polyurethane. You can add the kind of polyurethane, or you can add the amount of polyurethane needed. You can pretty much add anything as you like within this droplet. Let's move on to the next step here. So again, we have numbered our instruction here to make sure that they go in order. Here we see a vacuum hose. So the end user is bringing the vacuum hose into the box of polyurethane pellets. So our number one step, initiate vacuum hose of the hopper to lift the pellets into the hopper. 2, set the speed of the vacuum hose to 25 meters per second. And then the third instruction, set the amount of pellets needed into the hopper to 4 liters. So you may have a system where you can indicate all of these instructions, and then you can show the arrows of the pellets being lifted here. So you could, there's different ways of how you can use these annotation to make it more interactive to the end user that's following the step-by-step process. So pretty straightforward here. Moving on to the next step, you can set countdown timers to make sure you are holding the vacuum hose into the box for 50 seconds to make sure that it does take out 4 liters into the hopper. Countdown timers can be set in any way as you like. There might be different processes where you may need countdown timers so they don't just, suck in the resins, for example, for 20 seconds or 10 seconds where you might not have 4 liters. At least with this countdown timer, it ensures that that you stay for 50 seconds, so it takes all of the resins that are needed into the hopper. So we'll just close this. So 10 seconds, you pretty much all of the resins are into the hopper now. So as you can see, these are clearly indicating which is what. We've indicated that this is the hopper, this is the vacuum hose where the resins are being pulled to be input into the hopper. We have the integrated drying system. And then we have a picture-in-picture annotation, which is a different type of annotation that you can use where you are adding multiple images onto your picture step to convey your instruction. So here it's saying turn on the integrated drying system so no moisture gets into the extruder. So you have a control panel for this integrated drying system where you're essentially turning it on so it is running so there's no moisture that gets into the extruder. Again, this is an important step. You don't want moisture in the extruder. This might mess up the process. Let's move on to the next step. Gather color palettes. Let's look into this notes. Blue palettes needed to add coloring to the tube. Again, this is optional. If your process does not need color to add coloring to the tube, you don't need this process. This process is only needed if you're adding coloring and you have separate palettes to add your color palettes into a color hopper. So our first step, add 4 liters of coloring palettes into our 4-liter bucket. Number 2, add the bucket full of color palettes to the color hopper. So here it indicates a color hopper. Again, you have the main hopper, which is at the top of the extruder. Then you have the small color hopper to add the color palettes. Before going on to the next step, we have a self-inspection form. Ensure that 4 liters of blue pellets has been added to the color hopper. If not, add more until it reads 4 liters in the system. Again, this is very crucial to make sure that you add 4 liters of blue pellets into the color hopper because you want to add the same amount of color pellets as your polyurethane pellets that you've added on the top hopper. So we'll validate that it's 4 liters. It reads 4 liters into the system. Save that information. And again, all these information that you're saving and inputting gets stored into a production report, which you can access. So the administrator or the quality inspector or the supervisor can always access these production reports and see and validate or even track your end users on how they've collected these data and also collect the productivity monitoring. Coming on to this next step, turn on the extruder. So we're getting close to initiating the extrusion process. Set desired temperature of each heater in the extruder to melt the pellets completely and mix in the feeder. So here we've added a multiple image again to kind of highlight our instruction, and we've added droplets. We've seen a droplet in the previous step here. Now we've added blue droplets. So we've seen yellow droplets. Yellow droplets indicates that you're adding nodes. Blue droplets basically means operation. So you're dealing with a sequence of operation. So let's say the end user presses next, it goes to the second one. Make sure you put that as your reading to your second heater, heater number 3, 401, and then you have your pump heater, which is rated at 395, and then you have your extra zone, which is rated at 394. So all this needs to it needs to be ensured that you are following all of these and setting it at the right temperature so you can follow the process efficiently. Moving on to the next step here.
Be careful of the incoming extruded plastic from the feeder. It is HOT.
So again, you have this alert notification. You can add alert notification at any point within your work instruction. If there's any cautionary or any warning step, this is very useful. So here you can activate the audio notification or you can deactivate it and have this dialog box written as be careful of the incoming extruded plastic from the feeder. It is hot. Extrusion process 1. With the resin ready and the extruder preheated, begin the extrusion process. So if we go into this picture here and on this note, enter code 3456 and hit enter to begin the extrusion process. So you might have a control panel where you might have to put in a code to initiate any type of processes. You can enter that into a note instead of creating a text annotation and have more text in your picture step. Again, this is just, it simplifies and makes it easy for the eyes for any type of end user to come and follow the step-by-step process. Moving on to the right-hand side, we are indicating each parts of the process, the feeder, the opening die, and the extruded plastic. So as you can see, the extruded plastic is oncoming from the opening die. 2, the extruded plastic will now come out of the opening die. And 3, wait a few minutes for the temperature of the extruded plastic to stabilize and for the color to get into spec. So in the beginning, you'll probably see like a very, very light blue color of the extruded plastic. You want to make sure that you get the right color in order to be into spec. And if you want to validate that, of course, this is where your forms come in. So you can add as many forms as you like. If you see that there's a lot of forms here, it's because we've added that many forms into this thing to make sure that every step of the way is validated. The extruded plastic coming out of the feeder should be dark blue before going to the next step. If not, wait until it is dark blue. So let's say you're still seeing light blue. You should not move to the next step unless you see it's dark blue in order to get the right color and to make sure that the temperature is stabilized. So we'll validate that yes, move on to the next step. So with the oncoming extruded plastic, you have a blob that has fallen onto the ground. So you want to make sure you get rid of any excess extruded plastic. And you're pulling out the stabilized extruded plastic from the feeder to the cooling trough. So you can see here that this end user is basically pulling out the stabilized extruded plastic from the feeder to insert it into the cooling trough here. Moving on to the next step, you're placing a cool water onto the hot extruded plastic to form its final shape. So from the feeder, when it's coming out, you want to make sure that cool water is being sprayed. If we go on to this note, we'll see why this water is being sprayed onto this extruded plastic. The cold water is there to solidify the extruded plastic into the tube that we want. And the next step is move the tube across the trough gently under a series of rollers in order to keep it underwater. So as you can see, he's gently moving it across the trough. And you want to make sure that it's under a series of all of the rollers here to make sure that it's underwater and being cooled across the trough. That's what gives the hardened feel of the tube. At the end of the trough, feed the tube into the laser machine to get the outer diameter readings. So after the trough, you have to insert the tube into a laser machine to get some outer diameter readings. And here you can collect these readings by creating a form. So you're collecting the outer diameter data from the laser machine. What is the upper and lower values respectively of the OD calculated by the laser machine? So you would do respectively, the upper limit is, let's say, 0.38, and the lower limit, let's say it's 3.376, for example. So as soon as that gets saved into an information, that's the reading that you got from the laser. And then what you can do is, with VKS, we do have SPC as one of our elements, which is statistical process control. So if you're looking into, so if you do deal with statistical process control with your process in your workshop, this just makes it easier because everything is calculated and everything can be monitored by showing you the chart instead of you physically doing that on your shop floor with your paper-based work instruction. So we have two types of SPC charts that you can use. One is product measurement and one is process measurement. With product measurement, you can track the performance of a dimension or criteria for a specific part number, while process measurement can track the performance of a criteria for a specific process that multiple parts are passed through. So just to show you an example, this is a process measurement example, and we've listed out extruder number 1 and extruder number 2. So let's say you are dealing with multiple machines where you need to, lay out this control chart to those multiple machines. You can use process measurement. But let's say if you're dealing with just that one machine and you're not going to be changing that machine, you would use a product machine because it would just be specific to that one specific part number. So with the extruder number 1 here, we will record the measure of the outer diameter reading of the extruded plastic tube. So we'll put the upper limit that we received in the previous one, which is 0.38. And here it shows you what is the limitation, so you don't go out of the limitation. So you have your upper and lower limit, and then you have your lower warning limit and your upper lower warning limit. So here's some data that you can look into and some stats. We'll just save this information here. And let's say you want to view the control chart. You go on under elements, and then if you go into control chart element, you can view it by clicking on the eye icon here. So here it gives you a reading of multiple data that has been entered by either yourself or by other users by accessing this work instruction. So your 0.38 is somewhere here. This was the last reading from another operator and an operator before that. So you can kind of add data as much as you want to get a reading if it's within limitation, depending on how many cycles you go through. But since this is only one cycle, you only have one data. And with this, it shows you, all of the other data such as CP, CPK, standard deviation, and mean. And then you can look at the X and Y axes and kind of break it down and kind of see where it falls within your limitations. So this is a pretty interesting feature. So not only for your extrusion process, this can be essentially used for any type of processes if you're looking into statistical process control. Going on to the next step, here's a manual inspection. So we saw it calculated the OD digitally, but now we want to do a manual inspection to conform or to see if we're within the range there. So we take a piece of sample here and we take our calipers or whichever tools that we have to measure the OD. And before going to the next step, we have a quality inspection form for that here that would be popped up before going to the next step. So here with the quality inspection form, you can manually measure the outer diameter using the caliper as shown here. So let's say we get a reading of 0.377. Outer diameter must be within 0.3 to 0.4. Again, you can have these instructions here to make sure if it's pass or fail. We've got it pass, so that's a pass. Inspect for any surface imperfection, defects, or deformities. Everything looks good, you would pass. Let's say you put fail, you can put that here and make sure you have that supervisor sign off for whichever, quality that you've met with each of these criteria, and to make sure that the supervisor has validated all of the quality inspection points. We'll save that information here. Going to the next step, set up roller to coil up the finished plastic tube. And this is the end of process where your tube is coiled and ready to be packed. So we have detected that you have reached the expected quantity. Are you finished? Yes, I am. You have a quantity completed form that pops up just to validate that you have completed it at this time. So you have that criteria there. And then you have an optional form here asking you to leave a comment or feedback. Again, you can leave any type of comments or feedback as you like. And also take a picture of the finished tube coiled and packed. So these are just optional, just for, just to have a record of it, to make sure that everything is in place. And that's essentially the guidebook of the week for this week. I hope this was insightful, and I hope this was very informative for any of you looking not just for extrusion process, but pretty much any processes. Again, if you have any question or you want to learn more about our solution, please book a demo with us at our website at VKSapp.com today, or contact your VKS customer service representative. Stay tuned for more of our upcoming Guidebook of the Week series. I'll see you all on the next one. Take care. Bye.